What is Active Data Guard? As you're seeing on the screen, Active Data Guard is a read-only database plus it keep on applying the log. Before Active Data Guard, there was a data guard, and data guard was not a read-only database. It was only applying the log. People used to keep the database in mount mode and they were applying the log when they need it. They were stopping the apply log. They were keeping the mount mode database into read-only database. But with the concept of Active Data Guard, ADG is a read-only database. On top of that, it keep on applying the log. So we say that a real-time query is possible on primary and on the standby database. Remember, it's a real-time query. It means the select statement. It means reporting jobs, which can run now on the standby database, same as that of primary database. So what it does, it helps the primary database to relieve some of its reporting jobs, report intensive jobs, rather than to run on the primary database, better to run on the standby database. What is the background process which does the apply is MRP. The background process which does the apply is MRP process. MRP process is activated using alter database recover managed standby database disconnect from session. This command will start managed recovery process, which we call as MRP process. MRP process takes the log out from the standby log location and keep applying them on the database. We can see the status of MRP as shown instance ID 1 on which a process named as MRP 0 showing its status as applying log. You usually see either applying log or wait for log. We will learn about wait for log later on. Applying log is applying a sequence. Sequence number is given and the time of the sequence. By looking at this, we can say that our database is in sync up till this time, and this sequence is of thread 2 and the block number and the number of blocks of the block is applied or applying. So in total, what we understood as shown in the picture above, there is a primary database and there is a standby database. The primary database archives, redo logs are transferred to the standby database and MRP is applying those transferred logs to the standby database. And the job which is running there is a reporting job which is consuming the standby DB for reporting purposes. Any lag applying these standby logs, we will learn about standby logs later on. For the time being, we will say any lag applying archived redo logs to the standby. That time of lag is what we are not going to get in the form of reportings in our reporting job. For example, if there is a 2 hours of lag, it means reporting job would give us 2 hours before data. So real-time query should give the same data which is there on the primary also on standby. So if there is no lag, Realtek query gives that. Zero data loss. This is a new acronym tossed by Oracle in order to provide a protection for our production databases. The zero data loss protection is a new concept recently few years back evolved where if a data guard is set up between two distant locations, on location 1 you have primary production DB, and on location 2, which is miles away, you have standby database. You might be having a poor network bandwidth, you might be having very good network bandwidth, but the primary database, if kept in sync to that much long distant location standby DB, it is very hard for it to get commit from the standby database and on the primary database. So the concept of for sync instance comes in picture when zero data loss protection for production databases are given. A for sync instance takes redo transport in sync mode. The redos will come to for sync instance, and from there in async mode the redos will go to the standby DB. Sync and async are two terms which are very important when we talk about acknowledgement. When a redo transport is transported in sync mode, for each redo that is being transported to the for sync, the primary will receive a acknowledgement saying that the redo is received. For sync instance send that redo to the standby database in async. It means it won't get any acknowledgement. It simply send the redo to the standby database. The functionality help the primary database to transport logs in sync and keep itself alive. So zero data loss protection for production database by having a replica of the same as standby database at any distance, whether it is a neighboring data center, a data center in a different city, a data center in a different state, or a country, or a continent. It uses for sync instance. Remember, the for sync instance has to be in the nearby location of the primary database so that it can offload the actual redo transport job from the primary by taking redo transport in sync from it. So the location 1 should have primary DB and for sync we call it as primary DB in DC and DC as for sync instance. Location 2 is our DR.
Failover is a process of transitioning primary DB to standby database. When a primary DB is failed due to some reasons, the standby database takes the role of primary DB. There can be a number of standby DBs. Only one standby DB becomes primary DB during failover. Observer is required between primary DB and standby DBs in order to create a failover scenario. This process of transition to primary DB is called failover. A failover is unintentional, unplanned downtime. There can be a data loss or no data loss, but the failover will take place immediately. A manual failover can be performed by using the command failover to any chosen standby DB. There are two types of failover: manual failover and fast start failover. Fast start failover is also called as FSFO. In FSFO, the failure of primary database is automatically get detected, whereas in case of manual failover, this needs to be initiated. Observer is required in both the cases. Observer, if not able to connect primary database, at the same point of time, standby database is also not able to connect to primary database, then failover is initiated in FSFO mode by observer. Observer override a DG property if set to true in 12c R1, then the moment observer is not able to communicate with the primary database, a failover is initiated, no matter standby database is able to communicate with primary DB. In 19C, there comes enable fast start failover observe only. This command observe only mode initiates, which only logs the entry in the log that a failover would have been initiated but could not be done due to the mode observe only. This is a new feature in 12c where observer only observes but do not take any action of actual failover. It only writes an entry in the log. In 12c R2, there provided multiple observers possible. This helps high availability of observers, which makes if one observer, which is a master observer at any point of time out of multiple observers, fails, then the other observer, which is a backup observer, becomes master observer. It shows that if there are multiple observers configured in 12CR2 as a new feature, only one becomes master, other becomes backup observers. Backup observers comes in role only when master observer is not available.